Alright, so in this video we are going to see lower bound and upper bound function present in C++ STL. These are the important functions and they are widely used. So we will see in depth first behind the theory, its working, then its cases, then we will do a practical example also. Let's get started. First, these lower bound and upper bound, these can be used in containers like array, vector, sets, maps, and they are widely used in these containers. So it is a C++ STL function, and before using these functions, lower bound and upper bound, elements present in the container should be sorted. And that is so because it uses binary search algorithm internally. And we know binary search algorithm needs the list to be sorted. That's why the element should be sorted. Now we'll see what's the performance, what does it do. It returns an iterator pointing to the value which is just greater or equal to the value passed. So let's say we have a list of numbers 2, 5, 10 sorted in this ascending order. First we are seeing for increasing list. So here is the list, and now let's say we want a lower bound of some value, lower bound of value, let's say 5. Then since it returns an iterator pointing to the value which is just greater or equal to the value, so 5 is present in the list, so it is going to give us the output 5 because the value is present in the list. Let's say I take another example and I want the lower bound of value 6. 6 is not present, so it is going to give just greater. So which is just greater? 10 is the next greater element, right? 6 will come somewhere in between and 10 is the next greater. So the output will be 10. So this is what lower bound is. It returns an iterator pointing to the value which is just greater or equal to the value passed. So let's take another example. Let's take this time lower bound of value 13. Which will be 13, which is the next greater present in the list? 15, right? So 15 will be the result. So this is how lower bound performs in the sorted list which is in increasing order. Now, we will see the decreasing case in later parts of the video. Let's talk about upper bound a little bit. Upper bound, it is again a stale function. Element should be sorted because it uses binary search algorithm internally, and it returns an iterator pointing to the value which is just greater to the value passed. Even if the equal value is present, it is going to always give the next greater value. So let's take example 2, 5, 10, 12, and I say upper bound of 5. Upper bound of 5, value 5. So, even though the 5 is present in the list, it is not going to give this value, it is going to give the next greater value. So, which is the next greater value? 10, right? So, it is going to give the 10. So, this is just a slight difference that lower bound gives even the equal value if the present in the list, but the upper bound gives the next higher value or the next greater value. So let's take another example. Upper bound of let's say 6. Again it will be 10 only because the next greater value is 10 only. So this is how lower bound and upper bound works. And let's do on VS Code practically, and I will do the practical implementation on this on vectors and set, and if that's it's clear, then you are comfortable with lower bound and upper bound. So let's define our vector here, vector int v, and I will pass some values, random values 2, 4, 1, 77, 27. Now as told, it has to be sorted, so I will sort this using the inbuilt function sort. Now since it returns an iterator, so I need to define an iterator also. Iterator is nothing, just like a pointer. I have talked deeply about this in my first video. You can check that in, and you will get that video link also in the description. So iterator, and it has to point on where it has to point on the vector. So I will define the vector also. So our iterator is ready. Now we'll do lower bound. And here first we pass the range. We want in the full range, so I will say v dot begin, v dot end, because I want in the full range, and I will pass the value now. Here you need to pass the value. So let's take find the upper bound of this value. So, and I will display it. See out. Now you see here we have sorted, so our vector is now 1, 2, 4, 27 and 77. Okay, so now what will be the lower bound of value 4? Since 4 is present in the list, we will get 4 as the output. See, 4 is the received output. Now let's check for more. Let's take this time 14. What will be the lower bound of value 14? Since 14 is not there, so it is going to give the next higher element. So which is the next higher element present here? 27, right? So the output will be 27. Let's see. Okay. Now if I pass the value which exceeds the maximum value present in the vector, that means in this case 77 is the max value and we are passing 144. Now this value is not present, so it is going to give us the pointer to the end. So I will just show you here only. If iterator equal v dot end, then display not found. Not found, and it is giving some Vizare value. So that Vizare value is nothing. It is going to point at the end, and end is defined here, and it has some garbage value. That is what it is displaying here. Something. So this was the lower bound. Now here only, if I do upper bound, if I have to find the upper bound of let's say 4, what will be the output? Even though 4 is present here, upper bound always give the next higher value. So I will just here, the syntax is same. In place of lower we have the upper, and upper bound of 4 will be of course 27. Let's check this 27. Now upper bound of let's say 26, let's say let's say 75. 75 will be yeah, you are right, 77. So if I pass some bigger value exceeding the max element, again it gives the iterator not found because it is giving the garbage value present here. So this was how we gonna use the lower bound, upper bound in case of vector. Now you want to use the lower bound and upper bound in case of set. Then let's do this for set. So set, we don't have to do the sorting because internally the set stores the value in ascending order. So here I have created a set and passed declare and initialize some values of the set, and it is internally using the increasing order. It has been in the increasing order. No need to do the sort. sorting operation. Now I need to again define an iterator. I can use iterator I can, and it has to be this time of, it has to take set. So here is my iterator. I can also use the auto keyword. And even if you have any problem in these understanding or set how I'm writing this iterator, I have created the playlist of C++ STL. You can check that. Everything will be clear in the videos. Okay. So coming back here, I will say again I of lower bound. Again, I will pass the range s.begin, s.end, and I will pass some value here. Value you say 4. What is the lower bound of value 4? It is 4 only because it is present in the set. I will display it. They reference the pointer, iterator, and here we are. Now, let me just comment this out. And then 4 is the output. Now, if I want to do for some other value, let's say 14. 14. The lower bound of 14 will be 27 because the next higher value is. Similar is the case of upper bound also. But here I want to mark a difference. If I pass value which is exceeds the maximum value present in the set, then this time it is not going to give the iterator to the end. It gives the size of the set. So I have passed a value which is exceeding the max element. So this time it will give the size. So what is the size of the set? 1, 2, 3, 4, 5. So output will be 5. This is the 5. And in this point of time, I want to bring something to you. See, we are writing like this in case of set, but this is not the preferred way of writing in case of set. This lower bound like this, because when you write this, it works not in O of log n complexity, it works in O of n complexity. That is why you have seen sometime you may get time limit exceed error also, because the function is not working in log n time complexity, it is working in O of n complexity, and we know log n time complexity is lesser than O of n. So in case of set or map, we don't actually write like this. It is not the preferred way. We like this. I equal, we say s dot lower bound, and I just pass the value. Let's say 4. We write like this. Now this function works in O of log n complexity, and you can't use like this way in case of vector. Vector you have to use like this only. That is why to handle the TLE error, if you are using lower bound in case of set or maps, use like this, and it will still work in log n. It will still work in and it will work in log n time complexity. Alright. So this was it, and the same works goes with upper bound also. If I say upper bound, it gives the, even though it is present, it gives the next higher value. That means 27 will be our answer. 27. I think it is clear. Lower bound, upper bound, how to bring it in log n time complexity. And now we will see this in case of when the list is sorted in decreasing order. That means it is not in increasing list, it is in non-increasing order. In that case, lower bound, it returns an iterator pointing to the value which is just smaller or equal to the value passed. Which is just smaller or equal to the value passed. That means if I write here, let's take example 1, 2, okay, let's take 2, 4, 1, 77, 27. Now this is the list I am having, and I have sorted it in non-decreasing order. That means 77, then 27, then 4, then 2 and 1. Now if I ask the lower bound of let's say of value 3. So since it is in non-decreasing order, it gives the value which is just smaller or equal. So 3 is present? No, it is not present. So it is going to give the next smaller value which is 2. Right. So the output will be 2. I hope it is clear. Lower bound. Even if the value, it returns an iterator pointing to the value which is just smaller or equal. So it just reverses. Here when it was in increasing order, it was giving the greater. Now it is giving in a smaller. I can show you also. So here is our function. Now I will show you in the case of vector. So first we will sort this in. We will sort this in decreasing order. So we'll write greater int. Now I don't have like this. I have 77, then comes 27, then 4 to 1. Now I want for 3, right? So output will be 2 because it gives the next smaller value. And I will also pass here a function greater int because we need to tell we are using in a non-decreasing fashion. So, and I will make this lower bound. So everything remains same. Now I have sorted it in non-increasing order and I have passed the value and I have told the lower bound to perform it in a non-decreasing place. And I will comment this out and let's see what does it return now. It has to return 2, right? 2 because it gives the next smaller value. Now it is giving the smaller value. So if I say 4 is because present in the list, it will give 4 only because we are using lower bound. If it was upper bound, then what will it will give? Yes, you are right. It will give 3. It will give 2. Yeah, it will give 2 because 2 is present in the list. So and if I pass some bizarre, if I pass some big value, then it gives since it has to give the smaller value only. So the smaller value present is 77. So it gives 77. Now I will show you for set. Set by default it sort it in increasing order. But I will tell the set to make this number in non-increasing order. That means in decreasing order. So I will just write greater int, and now this will be in decreasing order. Now if I say 26, what will be the lower bound? Okay, I have to do it here. Lower bound of 26. It has to give the next smaller value. So 26 will come here. The smaller is 4. So output will be 4. Okay. 4. Simple, right? So I hope it is clear. And what as a summary, I just will explain here only. Lower bound, it gives iterator pointing to the value which is greater or equal to the value passed in case of increasing, and in case of decreasing it gives the smaller. And the upper bound, it gives, even if the value is present, it won't give that value. It is going to always give the next higher value. And if it is non-increasing, then it gives the smaller value. That's all. That's all you have to remember, and that's how we use this in the containers. Now, and there is a problem also related to this lower and upper bound. I will give the link in the description. You can check the lower bound in action when we have some problems and you're going to use the lower bound. Alright, so that's all in this video.